Mercury shouldn't exist. Not strange, not unusual, shouldn't exist. The smallest planet in the solar system, the closest to the Sun, the most visited by sunlight and the least visited by us. We have sent 2 spacecraft to Mercury in the entire history of human space exploration. 2. By comparison, we have sent more than 50 to Mars. For most of recorded history, Mercury was a footnote, a small bright dot that flickered near the horizon at dawn or dusk, blinking against the colors of the rising or setting sun. People who knew where to look could find it. People who didn't never did. It was the planet you forgot existed until somebody pointed at it. The version of Mercury that lived in textbooks was simple: small rocky world, hot side, cold side, cratered like the moon, closest to the sun. The end. Almost every sentence of that summary turned out to be wrong, incomplete, or hiding something we cannot explain. Start with the inside. Earth's iron core takes up about 17% of our planet's volume. Mars's is roughly the same. Venus, similar. Mercury's core takes up about 60%. 60. Imagine an apple where the core is everything except the skin. That is Mercury. A planet that's small should have a small core. The standard models of how rocky planets form predict cores of around 30% for a body in Mercury's neighborhood. Mercury's core is double that. The mantle is so thin it is closer in proportion to a thick coat of paint than to a planetary layer. Nobody fully agrees on why. The leading theory is catastrophic. Sometime in the first 100 million years of the solar system, while the inner planets were still forming, something hit proto-Mercury. Hard enough to strip away most of its rocky mantle and fling that material into space. What was left was the dense iron heart with a thin crust of survivors. It is the same kind of impact that is believed to have created Earth's moon, except Mercury was on the receiving end rather than the witness. Computer simulations published over the past decade can reproduce Mercury's bizarre composition only if the impactor was massive, the angle was specific, and the timing was precise. Even then, models leave residual questions. The geochemistry does not always match. The volatile elements that should have been blasted off in such an impact are still present in Mercury's crust. They should not be. Something happened to Mercury early in its life that we have never seen happen to any other planet, and we are still trying to figure out what it was. That is the first thing wrong with Mercury. The second is the magnetic field. Mercury has one. It should not. Earth's magnetic field is generated by molten iron circulating in our outer core. Convection in that liquid metal creates electrical currents. The currents create the field deflects solar radiation around our planet, and life on the surface is possible because of it. The mechanism is called a dynamo, and it requires a very specific set of conditions. You need a liquid metallic layer. You need enough heat to keep that liquid moving. You need the planet to be rotating. And you need it all to keep going for billions of years without freezing solid. Mars had a magnetic field once. It froze about 4 billion years ago when its core cooled. Venus probably never had one. Earth's moon lost its early dynamo around 3.5 billion years ago. Bodies smaller than Earth tend to lose their magnetic fields because they cool too fast. The dynamo dies. Mercury is small, tiny, in fact. About 38% of Earth's diameter, less than half the volume of Mars. Its magnetic field should have died before the first multicellular organism appeared on Earth. It did not. Mariner 10, the first spacecraft to fly past Mercury in 1974, detected the field by accident. Engineers had not even bothered to design instruments to look for one. There was no reason to. A planet that small could not have a working dynamo. The detection was so unexpected that the first reports treated it as a measurement error. It was not an error. Mercury's field is real, it is global, and it is generated by an active core dynamo right now, today. NASA's MESSENGER probe, which orbited Mercury from 2011 to 2015, revealed something even stranger. The magnetic field is not centered on the planet. It is offset toward the northern hemisphere by about 480 kilometers, or roughly 20% of Mercury's radius. The southern hemisphere is more exposed to solar radiation as a result. Why this offset exists is unknown. A planet too small to maintain a liquid core has maintained one anyway. Whatever is happening inside Mercury's iron heart is something that should have stopped happening 3 billion years ago, and it didn't. The third thing wrong with Mercury is its orbit. For most of the 19th century, Mercury was the planet that broke physics. Astronomers had observed for decades that Mercury's perihelion, the point in its orbit closest to the Sun, was advancing slightly more than Newton's laws predicted. The discrepancy was tiny, about 43 arc-seconds per century, a fraction of a degree. But it was real, and it was consistent, and it could not be explained. Newton's laws were the most successful theory in the history of science. They had predicted the existence of Neptune. They described the motion of the moon, the orbits of comets, the trajectories of cannonballs. They worked perfectly everywhere we looked, except at Mercury. The French astronomer Urbain Le Verrier, who had used Newtonian mechanics to predict Neptune's existence in 1846, proposed in 1859 that there must be another planet. A small, dark, undiscovered world orbiting between Mercury and the Sun, gravitationally tugging Mercury's orbit and producing the anomaly. He named the hypothetical planet Vulcan. Astronomers spent the next half-century looking for Vulcan. They claimed sightings during solar eclipses. They built dedicated telescopes. They scanned the daytime sky for hours. The hunt produced false positives, scientific feuds, and at least one observatory's career-defining embarrassment. Vulcan never existed. In 1915, a patent clerk in Switzerland published a theory of gravity that treated space and time as a single fabric, curved by mass and energy. He called it general relativity. Among the first tests Albert Einstein ran on his new equations was Mercury's anomalous perihelion advance. The math produced 43 arc-seconds per century. Exactly. Mercury did not have a hidden planet pulling on it. Newton's laws were not quite right at extreme conditions, and Mercury, the closest planet to the Sun, sat at the edge of one of those conditions. The curvature of space-time around the Sun, predicted by relativity, was just strong enough at Mercury's orbit to nudge its perihelion forward by exactly the amount astronomers had been measuring for 60 years. The most ignored planet in the solar system was the planet that proved Einstein right. Now, consider how strange that is. We had been wrong about the laws of motion since Newton wrote them down in 1687. The evidence had been sitting there in plain sight in the orbit of a tiny world we mostly forgot to look at. For 2 centuries, every physics class in the world taught a theory that did not quite work, and the planet that broke it was the one we did not bother to study. Mercury rewrote physics, and the field it rewrote took 60 more years before anyone could send a spacecraft close enough to look at it directly. The fourth thing wrong with Mercury is its day. For nearly a century, astronomers believed Mercury was tidally locked to the Sun. The same way our moon shows only one face to Earth, Mercury was thought to show only one face to the Sun. One scorching hemisphere baking forever, one frozen hemisphere in perpetual night. Every astronomy textbook printed before 1965 told this story. Generations of students learned it. Telescope observations from Earth seemed to confirm it. The features visible on Mercury's surface from Earth-based telescopes appeared in the same places every time we looked. In 1965, astronomers at the Arecibo Observatory in Puerto Rico bounced radar pulses off Mercury and measured how the reflected signals were stretched and compressed by the planet's rotation. The result was a number that did not match the textbook. Mercury was not tidally locked. It was rotating. Slowly, but it was rotating. The orbit and the rotation are coupled in a way found nowhere else among the major planets. Mercury rotates 3 times for every 2 orbits around the Sun, a 3-to-2 spin-orbit resonance. What this produces is a day system that does not behave like any day system in the solar system. A solar day on Mercury, the time from one sunrise to the next, lasts 176 Earth days. That is twice the planet's year. From Mercury's surface, the Sun does not move steadily across the sky. Because Mercury's orbit is highly elliptical and its rotation is locked into that strange ratio, the Sun appears to rise, slow down, stop, reverse direction for several Earth days, stop again, and then continue rising. It happens twice during each solar day. If you stood on Mercury at the right longitude, you would watch the Sun set twice in the same day and rise 3 times. For 90 years, we believed Mercury showed one face to the Sun. We taught it. We printed it in books. We built models around it. We were wrong. The planet's relationship with time is broken in a way we have not seen anywhere else, and we did not realize it until 60 years ago. The 5th thing wrong with Mercury is the ice. Mercury's surface temperature on the day side reaches 430 degrees Celsius, hot enough to melt lead. The night side plummets to minus 180 degrees Celsius, one of the most extreme temperature swings of any body in the solar system. In 1992, ground-based radar observations detected unusually bright, reflective patches at Mercury's poles. Patches that looked, from a radar signature standpoint, suspiciously like water ice. This was not supposed to be possible. The planet closest to the Sun should not have water ice anywhere on its surface. What it does have at the poles are craters. Specifically, craters whose floors are angled in such a way that sunlight has never reached them. Mercury's axial tilt is essentially 0, just 2.04 degrees, the smallest of any planet in the solar system. That means the bottom of a deep polar crater on Mercury sits in permanent shadow, forever. No sun has touched the floor of these craters in the entire history of the planet. Inside those shadows, temperatures hold at around minus 170 degrees Celsius, cold enough for water ice to remain stable indefinitely. NASA's MESSENGER probe confirmed the ice in 2012 using a neutron spectrometer. The estimated reserves are between 100 billion and 1 trillion tons of water ice locked in permanently shadowed polar craters on the planet closest to the Sun. The leading theory for where it came from is comet impacts. Comets striking Mercury over billions of years deliver water, much of which sublimates immediately under the punishing solar exposure, but a small fraction of which migrates as vapor toward the cold polar craters and refreezes into the shadowed bottoms. A planet that close to the Sun harbours more water ice in volume than some entire glaciers on Earth, sitting in darkness so absolute that no photon has ever reached it. We have only sent 2 spacecraft to Mercury, Mariner 10 in 1974 and 1975, made 3 flybys. It mapped about 45% of the surface during fast passes. It detected the magnetic field and produced the first close-up images. Then it ran out of attitude control gas and was abandoned in solar orbit, where it presumably still drifts today. 37 years passed before the next mission. NASA's Messenger, launched in 2004, took 6 years and 15 planetary flybys to slow itself down enough to be captured by Mercury's gravity. It entered orbit on March 18, 2011. For 4 years it mapped, measured and photographed the planet at unprecedented resolution. It confirmed the polar ice. It mapped the magnetic field. It revealed features called hollows, small irregular depressions found nowhere else in the solar system, possibly caused by sublimating volatile materials that survived for billions of years and only recently began evaporating. In April 2015, Messenger ran out of fuel. The mission ended the way every Mercury mission seems to end, by the spacecraft slamming into the surface. Messenger hit the planet at over 14,000 kilometers per hour, leaving a fresh crater that is still there, still dark, still warm with the residual energy of impact. Even after Messenger, we have detailed coverage of only about half of Mercury's surface. Polar regions, certain longitudes, terrain in shadow during the spacecraft's orbital geometry, all of it remains undermapped or unmapped. The ESAJAXA mission, BepiColombo, is on its way, currently in transit. It performed its 6th Mercury flyby in January 2025 and is scheduled to enter orbit on November 21st, 2026. 6 months from now, we will have a probe orbiting Mercury for the first time in over a decade. The flyby data BepiColombo has returned so far already suggests anomalies in the magnetic field configuration that Messenger did not capture. There may be more dynamics, more variability, more activity than even our most recent dataset suggests. If that is true, our understanding of Mercury's dynamo is about to be revised again. We will look back on 2026 the same way we look back on 1965 and 1974 and 2011. Each time we get closer to Mercury, we discover the planet is doing something we did not expect, and the textbooks have to catch up. Mercury is the planet we ignored, and almost everything we know about it began as a surprise. A core too big. A magnetic field that should not exist. An orbital wobble that broke Newtonian physics for 200 years. A rotation we miscounted for 90 years. Ice in the most exposed location in the inner solar system. Surface features we cannot fully explain. A history of impacts that scrambled our models of planetary formation. And data from new missions that suggest we still are not quite right about any of it. Astronomers have a saying that Mercury is the toughest planet to send a spacecraft to. The Sun's gravity well is so deep that any probe approaching the inner solar system has to shed enormous amounts of velocity to avoid simply falling into the Sun. Reaching Mercury takes more energy than reaching Pluto. That is part of why we have only been there twice. The other part is that for most of the space age, nobody thought Mercury was interesting enough to justify the cost. We were wrong about that too. The planet most people forget proved Einstein right. The planet without enough heat to keep a core liquid kept its core liquid. The planet too close to the Sun for ice has more ice than some Antarctic glaciers. The planet we thought was tidally locked rotates in a pattern that breaks daytime as we understand it. And in 6 months, a probe arrives that will probably tell us we were wrong about something else. The pattern is not random. The same thing that makes Mercury hard to reach is what makes it interesting. It sits at the edge of one of the most extreme environments in the solar system, scoured by solar wind, baked by radiation, pulled by the gravity of a star that is barely 58 million kilometers away. Anything in that environment is going to behave in ways that surprise us, because nothing else in the solar system has spent 4.5 billion years that close to the furnace. And yet, we forget Mercury exists. We look up at night and see the bright dots and we name them: Venus, Mars, Jupiter, Saturn. Mercury, the brightest of the inner planets at certain times of year, is barely visible because it is too close to the Sun to escape the glare during evening hours. You have to know where to look. You have to be in the right place at the right time. Most people never see it. Most people will live their entire lives without once putting their eyes on Mercury, even though it is right there, every night, painting itself across the sky in light that has been bouncing off it for 4.5 billion years. We could not see it clearly enough to understand it from the ground. We have only managed to send 2 robots close to it, and every time we have managed to get a closer look, the planet has shown us something that did not fit the theory we walked in with. The smallest planet rewrote physics. The closest to the Sun keeps ice. The fastest to die kept its core alive. The one we ignored for centuries is the one whose data still keeps breaking our models. In 6 months, BepiColombo will take its place in orbit and start sending back the next round of surprises. We do not know what they will be. We only know that there will be more, because every single time we have looked at Mercury, there have been more. The pattern has held for 50 years. There is no reason to think it stops in 2026. Maybe Mercury never had a chance to be boring. Maybe a planet that close to a star, with that much energy pouring through it, with a history that violent in its first 100 million years, was always going to end up being the planet that broke the rules. The planet that should not exist and yet does, sitting there, doing its 3-2 dance, holding ice in its shadows, generating a magnetic field it should not have, in an orbit that needed Einstein to explain. Mercury is not a footnote. It never was. We just kept treating it like one. Thanks for watching, and I'll see you in the next one.